So this is test number 6. This test is mainly based on refraction. If you continue to learn the remaining part of the lesson light, you need to have a good understanding of refraction. This test will be useful to gain that knowledge. Okay, the first question. When a light ray moving in a denser medium enters a rarer medium, so they have given speed, wavelength and frequencies. So what they ask is, as this happens, what happens to that property, right? So there's this light ray and the dense medium and the rare medium. Okay, so this is the equation. V equals f lambda is the equation applied for waves. We know that frequency does not change. It is a constant. As the medium changes, when the medium changes for the wave, frequency does not change. Frequency does not change, right? Only the velocity and the wavelength can be changed. The other thing you have to know is in a dense medium, we have low speed. In a rare medium, we have a higher speed. As you can see, velocity and wavelength, for this case, it is proportional. So the wavelength also behaves the same. So in the denser medium, wavelength should be less. In the rare medium, wavelength should be larger. Like that. So then you just have to choose an option for that. So in the rare medium, what happens? Wavelength, actually the wavelength increases, right? We don't have any other option that suits this theory. Wavelength increases. Actually the speed also increases, but we don't have an option for that. So the answer should be fifth one in this case. Then the second question, refractive index of diamond is 2 if the light speed in a vacuum is 3×10⁸, light speed in diamond is, right? So they have given a refractive index of diamond as 2. Refractive index of diamond as 2. Since this is an absolute refractive index, you can use this equation. C is the speed of light in a vacuum and V is speed of light in another medium. In this case, it should be that should be diamond, speed in diamond, right? Then you just have to say substitute these values. This equation only can be applied if you have given a absolute refractive index. If they have given a relative refractive index, we'll see how to do that. But in this case, you can put C here only if this is an absolute refractive index. Okay, right? So n is 2, speed in a vacuum is 3×10⁸. Then you have to find V, speed of light in a diamond. So V is, if you cross multiply 3 divided by 2, that is 1.5 10⁸ meters per second. So speed in a diamond is less, right? Because diamond is the denser medium compared to the vacuum. So it is 1.5 10⁸ meters per second. So the answer should be fifth one. Okay, answer should be fifth one. Then we'll move on to the third question. In air, wavelength of blue light is 420 nanometers. 420 nanometers. Refractive index of the light in water is 4/3. Wavelength of blue light in water is, okay. So the here as well, the other medium is air. We have air and water. Those are the two mediums. So in this case as well, we can use the same equation, this equation, because we only need the absolute refractive index, okay, because other medium is air or vacuum. So we can simply use this equation. Right. I can simplify this equation like this. So n equals, I'll just rewrite the equation, c divided by v. So this c, we can say frequency, instead of c I can say frequency times lambda naught. Frequency times lambda naught. So lambda naught is wavelength in the vacuum. So then this v, frequency lambda. Then I can say this n is equal to lambda naught divided by lambda. Frequency gets cancelled off because it does not change, right? Frequency does not change as the medium changes. Only the wavelength changes. So f cancels off. Okay, then we can use this equation. N equals 4/3 absolute refractive index. Lambda naught. Lambda naught, have they given lambda naught or lambda? Lambda naught is the wavelength of blue light in air, or we can say in a vacuum. So that is 420 divided by lambda. So we need to find this lambda. Lambda is the wavelength of blue light in water. Okay. Then cross multiply. 3 goes here, 4 goes below, 420. 1, 1, 0, 5, 315 nanometers. So lambda is 315 nanometers. So that is the wavelength of light in water, right? 350 nanometers. So the answer should be third one. Okay. When you use these types of equations, you have to clearly identify which one is which, right? So when you have two mediums, you have to be careful when you're substituting to these values, right? If you didn't understand how to clearly identify whether this is a vacuum or whether this is another medium, rewatch the video, right? If you mix these two, you will get a wrong answer, right? You have to carefully understand which should be at the denominator and which should be at the numerator. Okay, right. Fourth question. If refracted ray and reflected ray moving from air to glass are perpendicular to each other, incident angle is, right? So this is moving from air to glass, right? Let's say this is air and this is glass. Glass could be above and air could be below as well, right? But here I'm choosing air to be at the top. So air, glass. Then a light ray is incident on this interface. Then let's say this is I. That is incident angle. So you know, whenever there's a wave being incident, there's always going to be a reflection of that wave. We call that reflection a partial reflection, right? Around 20% of this light gets reflected, not refracted. About 20% gets reflected. Okay, then 80% of this wave gets refracted. This is a refracted wave, and this is reflected wave, right? Reflected. So what they say is angle between reflected light ray and refracted light ray is 90 degrees. So that's what they say. Then what they ask is this simple I, and this is simple R. Since this is air, if you remember, we can apply the previous equation. this one, n equals c divided by v. You can apply that equation. There's a better way doing that, right? Because this is like somewhat looks complicated. You can apply this, but you can apply this equation. It is always safe to apply this equation. n1 sin I, n2 sin r. This is the same equation, but this one is a bit safer to apply, because you won't get confused whether which one to be at the denominator, which one to be at the numerator. You won't be confused when you apply this equation, right? Okay. So for air, we know that refractive index is 1. For glass, they have given 3/2. So 1.5 is 3/2, right? 1.5 is 3/2. So I'm putting it as a fraction, because simplification will be easier in that case. Okay, so for air, refractive index is 1, sin I, everything at this side equals everything at the other side. N2 is given as 3/2, which is 1.5, then sin R. So we have this combination, right? Then we are going to need a little bit of geometry to have another combination between simple I and simple R. Okay, so this is I, and that other one also is I. Then we can say this angle 90 minus I, then this comes 90 degrees minus I, then this angle 90 minus R, 90 minus R. There can be other combinations as well in order to get this, but I'm choosing this one, right? It's a little bit of geometry in order to figure out this angle. So we know that this angle and this angle, the sum of both these two angles is equal to 90 degrees. So 90 degrees, this whole thing is 90 degrees equals 90 minus I plus 90 minus R. 90 cancels off, minus comes to the other side, then I plus R equals 90 degrees. Okay, so we have another combination for this. I plus R equals 90 degrees. Then I'm going to, so what they ask is incident angle. What they ask is incident angle. So I'm going to subject R, then this is 90 minus I. Then I will substitute this 90 minus I here. Let's say first one. So from 1, sin I equals 3/2 sin R. Sin R means 90 minus I. Okay. So sin I equals 3/2. This is cos I. Cos I. Then you can divide this in order to make a tan. So tan I, sin I divided by cos I, cross multiplying. Sin I divided by cos I, that is tan I, equals 3/2. Okay, after that we can get a value for I, that is tan inverse 3/2. Value for I, tan inverse 3/2. Let's check whether we have something like that. Okay, the third answer, right? So 3/2 is 1.5. So tan inverse 1.5, that is the incident angle. So we have a value for this. Okay, if you want, you can find that angle in degrees using the logarithm book under the tan table, right? But they haven't asked that. They asked the value in terms of tan inverse. So you can keep it like this. So the answer for that question is the third one. Right, fifth question. At the center of a glass sphere with diameter 12 centimeters, a point object is placed. If the refractive index of glass is 1.5, distance to the apparent position of the point object from glass surface is, right? Okay, so like many students have treated this question like that glass surface as a plane surface. Here the surface, the interface is not plane, right? So it is a spherical surface. So you cannot use this equation. You cannot use this. Remember, if this equation was derived for glass slabs, that interface should be plane, right? Not spherical. So here you cannot use this equation. So I'll just draw what happens here. So there's this glass sphere, and at the center you have the object. Then let's think about a ray, light ray coming from this object, like this. So as it is incident on this surface, interface, glass air interface, this angle is 90 degrees. So 90 degrees meaning that this ray does not deviate to other sides. So it just goes like this, right? So if you think about another ray, any number of rays, none of these rays deviate from their path, because all the rays are incident at 90 degrees, because these rays moves along a radius all the time, because the object is at the center. So what happens? If you think about these two rays, then you can think about the position of the image. As you can see, these rays meets at the same point. So the image also is formed on the position of the object, right? So these two object and the image, they coincide together, right? Coincide together. Then distance to the apparent position from the glass. So this is the apparent position of the object, image, right? So they have given 12 centimeters as the diameter. So from the glass surface, distance to the apparent position should be 6 centimeters, because that's the radius. Okay. In this case, the image does not actually have a apparent displacement. Okay, so the answer should be 6 centimeters. 6 centimeters. Second one. Right, sixth question. A point light source is placed at the bottom of a tank with depth 2 meters. Light emits from surface of water within a circular area. If the refractive index of water is simple n, radius of that circle is. Okay, so this question has refraction and about total interreflection and critical angle. So this question is about that, right? Okay, so let's say this is the water surface, and you have this point object at a depth 2 meters. So then what happens is, you can have a ray like this. Ray coming from this light source is being incident on this interface, water surface. You know, when it is critical angle, when this incident angle equals to critical angle, the light ray goes along the surface and does not have a chance to emerge. So that is a theory, right? I'm not going to explain the theory too much, okay? So if a light ray, then think about light ray like this, that has a less angle compared to critical angle. So these light rays emerges. Then if you think about a ray like this, the angle here is larger than the critical angle. So these rays, any ray incident beyond this point, submitted to the total internal reflection. So none of the rays being incident after this point have a chance to emerge to the other surface. So only the rays incident from here to here in this range, the rays incident within this range have a chance to emerge. So that emergence of those rays, so it looks like a circle, right? It has a circular area like this. So here what they ask is actually the radius of that circle. Radius of that circle, right? We don't need these rays. We only need the ray that has a critical angle. So we can find this simple R. We need a little bit of geometry after that. So if this is C, then this also is C. Right? These are parallel lines. So this is C, this is C. And the depth is 2 meters. Depth is 2 meters. Okay. Right. So I can apply a Snell's law to this angle, or you can directly use. Okay. So here the refractive index is it given? Yeah, it is n, simple n. Refractive index is AI is 1. So I'm going to use Snell's law to this ray. That is n1 sine I equals n2 sine R. If the question looks complicated, always use this one, right? So it is safe to use this. So n1 is the refractive index here, then sine C. This C equals n2 is AR, so that is 1. The refracted angle is 90 degrees, so R should be sine 90. So n sine C equals sine 90 is 1. Okay, then we can have sine C, equation for sine C, that is 1 over n. We have a standard equation for this one. You could directly apply this one as well, right? If you didn't remember that, you can derive that, then apply this. Right. Then I'm going to need, so we'll keep it from a side. Then I can write an equation for tan C. So if you think about this triangle, opposite side divided by adjacent side, that is tan C. So opposite R, adjacent 2. So from this we have cross multiply 2 tan C. So R is equal to 2 tan C. But what they need this one expression for R in terms of simple n, right? So from this I'm going to find a value, I mean expression for tan C in terms of simple n. So I can use this one. There are many ways to do this, but I'll choose this method. Let's say this is C. Then sine is opposite divided by hypotenuse. So opposite has a 1. So the hypotenuse should be n. And then this should be n squared minus 1. By applying Pythagoras theorem, you can find this side, right? Adjacent side. N squared minus 1. These are O-level stuff, right? I'm not going to explain too much. So this is R equals to tan C. Now you can have a tan C using this triangle. So tan C is opposite divided by adjacent. That is 1 divided by n squared minus 1. So this is 2 divided by n squared minus 1. Root of that is the radius. So the answer should be 5th one for that 6th question. Right, 7th question. One side of a glass cube with thickness 20 centimeter is painted with silver. Okay, so we have this glass cube. So I'm drawing a cross section. one side of that glass cube is painted with silver, so it acts as a mirror there. An object is placed in front of other side at a distance 40 centimeters. From the surface. Then image is formed behind 44.6 centimeters from the silver surface, painted surface. So then what happens is this forms an image behind this silver plate 44.6 centimeters. So there's the image, 44.6 centimeters. Then what they ask is the refractive index of the glass, right? So like many students have found this a bit complicated. There's a trick to do this question easily. There are other methods, but those methods are like somewhat complicated. There's a trick to do this question, right? If we follow that, then this question will be easier. Right. Here, I am going to treat this mirror as the object, as an object, right? Right. Other thickness is given, right? 20 centimeters. Right. Then if you look from here, so you are looking at this mirror from here. Then you can find the apparent position of the mirror. So we know that when it is a denser medium, mirror has an apparent displacement towards the front. That is apparent displacement. So I'll put that apparent displacement as simple d. Just treat this mirror as a normal object. So it has a apparent displacement to this side when you look from here. So now the mirror is shifted to this side. Then you can find the shift. How much is that shift? Simply apply this equation. D equals T1 minus N. T is thickness, that is 20 centimeters. 1 minus 1 over N. So this is a glass. They ask refractive index of glass. They haven't given that, so they're asking for simple N. Okay, so this is we have an expression for that displacement. We'll keep this aside. Right. Now, what is done by this glass cube is done to the mirror. Now you can forget the glass cube. Then think about this mirror only. Now there's only the mirror. So what does the mirror do? So actually the object is here. You know, to a mirror, object distance and image distance is the same from the mirror. Now the mirror is here, right? If you forget the glass slab, the mirror is here. Okay, so what is this? If this is simple d, then this should be 20 minus d. Right. So this is 20 minus d plus 40. 20 minus d plus 40, that is the object distance from the mirror, shifted mirror. So that distance is equal to this distance. So this distance is d plus 44.6. So according to that, the mirrors, you know that image distance and object distance. This is image distance, this is object distance. So those two distances are the same. So this is 20 minus d plus 40 equals d plus 44.6. Put d to the other side, 2d. This is 60 minus 44.6. 0.4, 5.49 minus 4, 5. This is 5 minus 4, that is 1. 2D. Then D is equal to 7.7 centimeters. Okay, now we have a value for simple D. Then you can substitute that value here, then find simple N. Right? Simple D is 7.7, 20, 1 minus 1 over N. Then I'll divide this by 20 equals 1 minus 1 over N. I'll put 1 minus N here equals 1 minus 7.7 divided by 20. Denominator 20, 20 minus 7.7. So this is 3, 12 divided by 20. 0.3, 19 minus 7, 12, 12.3. So N is 20 divided by 12.3. Okay. So that is the refractive index of glass. 20 divided by 12.3. Actually, you have to do this. I mean, there's a 1, then 2 for 200. How many 12.3s? 200. No, 12.3. Then 0.7. I'll just do like this. 200 divided by 123. So 1. 200 minus 123. 7. 7. So 77. Then put 770. So how many 123s? If this is too complicated, you can use a logarithm. I'll put 6 here. 6, 18. Okay, we have 6, 7, 738. So 1.6 something do we have? Okay, we have two answers with 1.6. So we further have to simplify this. 2, 3, 32, 320. For 320 we have 2, right? Yeah, 2 something, then you can round it off to 1.63. So the answer should be the third one for that question. After that, that is a simple calculation. You can use a logarithm there if you want, right? To get the answer 1.628 something, I think. So the answer can be rounded off to 1.63. So the answer should be the third one for that question. Right. 8th question. Position of the image of P is at. So they have given an image like this. Glass slab. Another glass slab. Thickness of these are given. Then below 2 centimeters, we have the object P. So what they ask is the position of this P. I mean not P, I mean image of P. Right. So this looks complicated, right? You cannot keep applying these equations like too many times. The key to get the answer for this question is you should know that apparent displacement is independent of the position of the object below the glass surface. Position of the object. Right. We can neglect this part because that is just air. So that is this part is not responsible for refraction, right? So we can neglect this part and this high depth as well, because this depth, I mean the apparent displacement, is independent of these depths. Then we can consider this two glass cubes as a one cube with a thickness 3 centimeters, 1.5, 1.5. So you can consider it like this: a glass cube with thickness 3 centimeters. You can put it here, then neglect these parts. The reason is it is the position of the object below the surface does not have any effect on the apparent displacement. Okay, now we know the thickness 3 centimeters, 1 minus, so these are glass. It is given as 1.5. So 1.5 is 3 over 2, 2 over 3, 3, okay, 3 times 1 over 3. 1 minus 2 over 3 means 1 over 3. 3 times 1 over 3. So displacement is 1 centimeters. Displacement is 1 centimeters. That is apparent displacement. So what happens? This object has a displacement to this side, that is 1 centimeters. So above P, image is formed at a 1 centimeter height. So it should be 1 centimeter above P. Here is the image. So that's the position. So the answer should be second one. Okay. So this is an easier question, but you had to realize that this apparent displacement is independent of the position of the object. I mean position below the surface. Right. So those are taught in theory parts, right? Theory notes. Okay, ninth question. Incident angle for a ray which propagates from a medium with refractive index of simple n to air is simple I. True statement to satisfy total inter-reflection is. Okay. So we have this medium with refractive index n and air refractive index 1. Then we have this incident angle, simple I. So this incident angle has to satisfy the total inter-reflection. Right. So what's the main requirement? To have this total inter-reflection, this incident angle has to be larger than the critical angle. I should be larger than critical angle, so that is the requirement here. Right. So if this is air, I can have this equation for critical angle. This to apply this equation, this must be air, right? So you can apply this equation. N is equal to 1 over sine c. Remember, you can use this equation only if the other medium is air or a vacuum, right? Otherwise you cannot apply this. You can use usually Snell's law, that n1 sine I equals n2 sine r thing, right? But here you can apply this because this medium is air, right? Then I'll cross multiply. So sine c equals 1 over n. C is equal to sine inverse 1 over n. C is equal to 1 sine inverse 1 over n. Then I'll substitute it here. Instead of C, I can put sine inverse 1 over n. Sine inverse 1 over n. Then you can put this sine inverse to the other side. Then it becomes sine I greater than 1 over n. Sine I greater than 1 over n. So do we have a expression? you can flip both sides of this equation. So it becomes 1 over sine I n. Remember that when you flip sides of an inequality, this sign changes. It takes the opposite side. 1 over sine n greater than, less than, simple n. Okay, so the answer should be first one for the ninth question, right? So these stuff you learn in O levels, right? Whenever you flip both sides of an equation. You can other ways you can cross multiply and get the answer as well, right? In that case, you don't have to flip that. Let's see. You can put n here. Then you can put sin I to the other side. 1 over sin I. Still you get the same result, right? When you cross multiply, you don't have to put the other sign, opposite sign. But if you flip both sides, you have to get the you have to flip this sign as well, right? If it is too confusing, you can safely apply cross multiplying method, and you don't have to do any flipping of this sign, right? So here n is larger than 1 over sine I. N is larger than 1 over sine I. If it is the case, then there's always going to be a total internal reflection. So the answer should be first one. Okay, 10th question. Refractive indices of prism materials A, B and C are 1.4, 1.5, 1.6. Given that the prism angle of each prism is 60, so the prism angle is 60 degrees. The angles of minimum deviation are dA, dB, dC, right? So they have given a prism angle and the refractive indices. So you need to know this equation. So you have to do a comparison between these three. So the prism angle for all three is 60. D is minimum angle of minimum deviation divided by sine 60 divided by 2, that is 30. So when you compare these, you can see these are constants, right? These are just numbers, so constants. So when you have a higher D value, you have a higher simple n value. Higher simple n, higher angle of minimum deviation. Okay, because this is sine, right? Higher the angle, higher the sine value of that angle. So higher the D, higher the refractive index. Okay, so to this side, refractive index is increasing. If refractive index is increasing, D also should increase to that side. So dB should be larger, DC should be larger than that. So angle of minimum deviation as well is increasing to this side. So the answer, so DA is the smallest one, DA is the smallest one, DB, then DC is the largest. DC is the largest, DA is the smallest. So the answer should be the fourth one for the 10th question. 11th question. One refractive side of a prism with prism angle A is applied silver. On the other surface, a ray is incident at an angle 2A. And it is incident on the silver applied surface. After reflecting, it moves back along the same path. So according to the description, prism should be something like this. So one surface applied silver. Then there's this ray. Incident angle is 2A. Then this ray has to incident on the mirror like this, then only then the ray would reflect back and follows the same path. So for that to happen, this angle has to be 90 degrees. Then this is the prism angle. If this is the prism angle, using geometry, you can say that this should be capital A. Then I'm going to apply Snell's law here. That is N1 sine R I equals N2 sine R. So here N1 is 1, refractive index, sine I is sine 2A, equals N2 is the prism material, refractive index of prism material. Sine R here is A. Okay, so what they ask is simple N. They have given this equation, sine 2 theta is equal to 2 sine theta cos theta. You can apply that here. So here you have sine 2A. So that should be 2 sine A cos A, right? Equals n sine A. Then divide both sides by sine A. Then you have an expression for n, that is 2 cos A. So the refractive index of prism material is 2 cos A. So the answer should be the second one. Okay, so the 12th question. To prepare a spectrometer before doing an experiment, order of above processes is, okay. So A, we have leveling of the prism table, adjusting eyepiece, so cross wires of telescope can be clearly and sharply seen. Simple, C, adjusting telescope to observe parallel light rays. D, adjusting collimator to observe parallel light rays. Okay, so we have given 4. So what they ask is the order. Before using spectrometer, you have to adjust the spectrometer. So adjusting the spectrometer is the complicated process. Once you adjusted the spectrometer, then after that the experiment is easier, right? The thing about spectrometer is there's an exact order to adjust in that. You cannot skip a step or mix up the steps. You have to follow the exact order, otherwise you cannot adjust the spectrometer correctly, right? I'll just briefly explain how to adjust the spectrometer in order. This one in the exam as well, they have checked this many times, mostly in structured essay questions. So I'll just briefly explain how to do that. So we have this prism table, telescope and a collimator. This is called collimator. Collimator is fixed to the spectrometer. This is fixed. We cannot change the position of this relative to the spectrometer, right? But this telescope, you can rotate it like this. Okay. The prism table also can be rotated. I'll just briefly explain how to do this. First one, you have to adjust the telescope. Second, you have to adjust the collimator. Third, you have to adjust the prism table. So that's the order. Then there are sub steps. Adjusting the telescope. So you know, telescope has 2 lenses. So you're looking at from here, right? So this is eyepiece. Here we have the objective piece or objective lens. You have the eyepiece. These are the 2 lenses. So adjusting the telescope means you have to adjust eyepiece and objective lens. First you have to adjust the eyepiece. So when you adjust the eyepiece, there's a crosswire inside the telescope. So you have to focus these crosswires. So the rays coming from here will be like this. Those will be parallel rays. So first you have to adjust. So once you adjust the eyepiece, what you can see, clear image of crosswires from this side. Then you have to adjust the objective phase. So to do that, you have to focus a distance object onto the telescope. Then what you can see is, let's say a tree or something. A distant object means infinity, right? Object at infinity. So the rays coming from that object is parallel. Then on the crosswires, you will see an image like this. Clear image on the crosswires. Then you can say the objective is adjusted. Right. Then, so that is the, now the telescope is adjusted for parallel light rays. Then you have to adjust. I'll just draw the collimator here. Let's say this is rotated. Collimator cannot be rotated by, right? Let's say the telescope is rotated and fixed like this. Then this is the collimator. Collimator has a slit, small slit. By adjusting this lens, you can have rays like this. Then the emerging rays should be parallel rays. So the telescope adjusted for parallel rays can sense these rays. So that is the collimator adjusting. So once the collimator is adjusted, what you can see is a thin slit, image of the thin slit on the crosswires. So that is what you can see. After that, then you can adjust prism table. Prism table. You have 3 screws here. There's a procedure for that. I'm not going to explain the procedure. By adjusting these 3 screws on the prism table, you can adjust this one. Okay. So once you did all these steps in order and precisely, then you can continue with the experiment, right? Okay. So let's think about what should be the order. We have eyepiece. Option B is eyepiece. So that should be the first one, right? Then observing the adjust telescope to observe parallel rays. So C is adjusting the objective lens. Now the telescope is adjusted. Third one, you can adjust collimator. Finally, you can adjust prism table. So that is the step A. So these should be the steps B, C, D, A. So the answer should be second one. That is the correct order of adjusting the spectrometer. Okay, 13th question. In an experiment to find the prism angle of an acute angled prism, 2 readings for 2 positions of the telescopes are 302 20 minutes, 62 degrees 18 minutes. Prism angle can be, right? Okay. So when you find the prism angle, so you have to place the prism like this, then the prism angle here. For the 2 positions, though, this is for the collimator, right? These are 2 positions of the telescope. So what they have given is the readings for these positions of the telescope. So one reading is 300 to 20 minutes. Other reading 63 degrees 18 minutes, right? So as you can see, this angle should be less than 180. Okay, you know that this angle is also is equal to 2a, 2 times the prism angle. So this angle can be calculated by subtracting these two values. Let's subtract those two. 302 is 20 minutes, 60 degrees 18 minutes, 2 minutes, right? Then 2 minus 3, 2, that is 9, 3, 2. Okay, now we have this. We have 239 2 minutes degrees 2 minutes. Is this possible here? This is larger than 180, right? This is larger than 180 degrees. Actually, what we have got is not this angle, this angle. Whenever you have that case, you have to go for another step. That is, you have to subtract this value from 360. Right? Actually, what we got is this angle. What we need is this angle, that is 2a. To get this angle, we have to subtract this value from 360 degrees. 360 is whole thing. You subtract this value, then you can get this angle. Right? You only have to do that if these subtracted angles are larger than 180. Otherwise, you can directly use this to be equal to 2a. But here, since it is higher than 180, you have to subtract from 360. Right? Take a 1 degree from here, then this becomes 58 minutes. 58 minutes. Here 9, 0, 5, 2, 1. Right, then this value is actually equal to 2a. So 2a is equal to 120, 58 minutes. Divide by 2, 60 degrees 29 minutes. So that is the prism angle. So you only have to do this subtraction if you have this value to be larger than 180. Otherwise, you don't have to go for this, right? You can directly get this to be equal to 2a. But if you get a value larger than 180, you have to subtract that value from 360. Then you can continue with the answer there. Okay, so the answer should be 60 degrees 29 minutes. 60 degrees 29 minutes. That is the prism angle. Answer is fourth one for that question. Right. 14th question. Two monochromatic rays are incident on a prism with prism angle 120 degrees as shown by the image. If the refractive index of prism material is 1.44, two emergent rays are, right? Two emergent rays are, right? So we have this prism. The prism angle is 120. Okay. So these are the two rays. Those rays does not deviate, right? Because on this angle, this surface, they incident with 90 degrees angle, so that doesn't deviate. But here it gets to the deviation. supposed to go like this, but it deviates away from the normal, like this. Here as well, away from the normal. Right. So what they ask is this angle between these emergent rays, the rays that emerged. So we need this angle. Right. So clearly these two angles are not parallel, right? So you can remove those options. These angles are inclined, then you have to find that angle, this angle. After this point, it is a geometrical calculation. So here, or here, or here, I'll just use here. Let's say this angle is simple I. That is the incident angle from this side. Because I'm putting this because I need to use Snell's law to this surface. Normal, and this should be R. This is I. Incident angle, make with the normal. Always incident and refractive angles, those are made with the normal, right? So this is simple I, this is simple R. I'll just use Snell's law to this one. So refractive index is given as 1.44. N1 sin I equals N2 sin R. N1 means here that is 1.44. Sin I equals N2 is just air. N2 is other medium, second medium, that is air. So for air it is 1 refractive index. Sin R. So we have a combination between those two, right? So here we have sin R equals 1.44 sin I. Sin R equals 1.44 sin I. Okay, so we're gonna need another combination. I'll just keep this aside. Keep this aside. Okay. I'll just find this angle. This angle. You know, this one, this whole thing is simple R. Then this and this one, those two are equal, right? So this is simple I. R minus I should be this angle. R minus I. Since these two lines are parallel, if this is R minus I, this also should be R minus I. Because due to the symmetry from the both sides of this axis, this also should be R minus I. Right? Then this whole angle, I can say R minus I plus R minus I. So that angle is 2 times R minus I. 2 times R minus I. So that is the inclined inclination between these two rays. These two rays. Another one, we know the prism angle as well, right? Prism angle, this one, that is 120. Whole angle is 120. One side has a 60 degrees. 60 degrees. And this angle is 60 degrees. This angle is 60 degrees. These are parallel lines, 60. Then this should be 60. this whole thing is 90 degrees, then 90 minus 60 should be I. So I is equal to 30 degrees. I is 30 degrees, then you can substitute it here. 2 times R minus 30. Right? 1.44 sine I is 30. Sine 30 is half. So this is 0.72 sine R. Then I can say R is equal to sine inverse 0.72. Then substitute it here. R is sine inverse 0.72 minus 30 degrees. So this is the angle between these two emergent rays. 2 times sine inverse 0.72 minus 30. The answer should be the fifth one for that, right? So we just applied Snell's law, and we had to deal with some geometrical things, right? Right. So the answer should be fifth one. 15th question. A prism with an equilateral triangle cross section is made of a material with refractive index 1.732. Angle of minimum deviation and incident angle for it are, right? So the refractive index is given as like this, 1.732. When you see this number, you should know that this is equal to √3, right? I'll just apply this equation. So n is equal to √3. Prism angle, this is an equilateral triangle, right? Equilateral triangle. So the prism angle should be 60 degrees. Equilateral means all the sides are the lengths of each sides is the same, right? Equilateral. So prism angle is 60 degrees. Then just substitute that angle here. So √3 sine 30. 60 divided by 2 is 30. Sine 30 is 1/2. Put it here. √3 times 1/2 equals sine 60 plus d divided by 2. So √3 divided by 2 is sine 60 plus d divided by 2. Right? So we came here. So √3/2, you know that value, that is sine 60, right? So in that case, 60 is equal to this thing. Cross multiply 120, 60 plus d. So d is equal to 60. 120 minus 60 is 60, right? So this is the angle of minimum deviation, that is 60. Right. Then what they ask something else as well. Now we know the angle of minimum deviation. For the angle to have the minimum deviation, what they ask is then incident angle I. So to find the incident angle as well, we have some equations. Remember this, I1 plus I2 is equal to A plus D. That equation. At the minimum deviation, what happens? I1 is equal to I2. If you remember this graph, this is the deviation, this is the incident angle, and the least one, that is I1 is equal to I2. At that case, we have the minimum deviation. So this is These are equal, so I plus I is 2i. These are equal, right? You can use I here and I here. 2i equals a plus d. A plus minimum deviation, that is d. So 2i equals 60 plus d. 60 plus, we found d, that is 60. 120 divided by 2, that is 60 degrees. This is the incident angle, right? So the incident angle 60, angle of minimum deviation also is 60 degrees. So the answer should be fourth one for the 15th question.